Have you ever been staring at a spec sheet and you see that little feature called 3D NR and you just kind of shrug and move on? I'm here to tell you that little acronym might be the single most important thing standing between your night videos and a grainy, unusable pile of sand. It's that grainy, almost snowy static that just flickers and dances all over the place, and it hides all the beautiful details you were actually trying to capture in the first place. That pile of sand that's ruining your shots, it actually has a technical name. It's called digital noise. And for this explainer, it is the absolute villain of our story. Think of digital noise as just visual interference. It's the storm of totally random, unwanted pixels that have no business being in your image. They just pop up out of nowhere. They mask the real details underneath, and they instantly make your footage look cheap. So where does this junk even come from? It's actually a predictable and pretty fascinating result of basic physics. Let's break down exactly how it happens. So it's basically a chain reaction. First, when you're shooting in low light, your camera's sensor is literally starving for light, for information. To try and see better, the camera artificially boosts the electrical signal it does get to make the image brighter. This boost is called gain. But, and this is the big but, here's the problem. When it boosts that image signal, it also boosts all the tiny background electrical interference that's always buzzing around in any electronic device. And that interference is what shows up on your screen as those random flickering noise pixels. But what if there was a way to intelligently clean all of that mess up? So let's meet the hero of our story, 3D NR. 3D NR. It stands for 3D Digital Noise Reduction. Now, this isn't a physical filter you screw onto a lens. It's a powerful algorithm, a really smart piece of software that is specifically designed to hunt down and eliminate that grainy mess. So what's the whole 3D part about? Now, it's got nothing to do with 3D glasses. The first two dimensions are exactly what you'd think, the width and the height of the video frame. But the third dimension, the secret sauce, is time. And that is what makes this technology so incredibly cool. How in the world does a computer algorithm see through time to clean up a video? It's actually a brilliantly simple idea when you break it down. Just think about any video for a second. The real objects in your scene, say a building or a parked car, they're consistent, right? They're in the same spot, frame after frame after frame. But digital noise, it is completely, totally random. A little noise pixel that shows up here in one frame will be gone in the very next, and a new one will pop up somewhere totally different. 3D NR is just smart enough to know the difference. So here's how it actually works its magic. The 3D NR algorithm looks at a whole sequence of frames all at once. It sees those pixels that are flickering around randomly and changing from one frame to the next, and it correctly says, aha. That's noise. At the exact same time, it sees the objects that are consistent and static, and it preserves them. And then, for the final brilliant move, it merges all the clean parts from those different frames together to create one single pristine image. It's like a time-traveling janitor for your video. It looks into the immediate past and the immediate future of the video frames. It scrubs away all that random digital dust, and it leaves behind only the clean, clear image that was supposed to be there all along. Sounds pretty amazing. A technology that can clean up your video, but there's a catch. This isn't standard on every device that shoots video. If this tech is such a game changer, why isn't it in everything, from our phones to our basic webcams? And the answer is actually really simple. It takes a massive amount of raw processing power to pull this off in real time. This analogy really explains it perfectly. Your basic, simple noise reduction, that has short-term memory. It only looks at the pixels inside a single frame to try and smooth things out of it. But 3D NR needs long-term memory. It has to hold multiple full-resolution video frames in its processing brain to be able to compare them all. You need a powerful processor to run the algorithm itself, and you need enough of that memory to actually store multiple high-res frames at once. It's a really heavy technical lift. So let's bring this all back home. Why does understanding this tech actually matter to you when you're looking at your next camera? The next time you see 3D NR on a spec sheet, don't just see it as one more feature in a long list. See it as proof. It's proof that the device has a high-performance brain inside of it. It's a direct indicator of quality engineering. And the ultimate result, for you, the person actually using the camera, is exactly what you wanted from the very beginning. A clean, detailed, and silky smooth image, even when the lights go down. No more piles of sand. Now that we've solved for all that noise, have you ever wondered why some video motion looks incredibly buttery smooth, while other motion just looks like a blurry, choppy mess? That is exactly what we're going to be breaking down in our next explainer. We'll see you then.